Welcome. I'm Dr. Craig Wright from Sturt University, School of Computing and Mathematics, and today's webinar is the first in a series on researching at the doctoral level. Tonight's webinar is around qualitative and quantitative research methods. So we're going to look at different techniques and how they apply in computing research. And in particular, we're going to look at some of the different issues that you'll experience as a doctoral student doing a professional doctorate such as the DIT, which is Charles Sturt's Doctor of Information Technology. So let's go through and start thinking about our research problem. The first issue we're going to have is this actually something that matters? What is our research problem? Is it significant? Are people actually interested in our problem? Is it novel? Is it important? High risk, high cost, etc. At the end of the day, we need to understand whether others are going to have interest in this and whether this is going to be something that matters. Is it novel? How can we study it? Now, there are many research problems that aren't actually possible to be studied at the moment. So we have to find things that are within our different budgets, our time frames, etc. to study. And we need to know whether it's relevant and interesting. And in particular, it needs to be of interest to you, yourself. If you are not interested in this line of research, then you're going to have a big problem actually finishing all of this. You need to be able to have an interest that's going to sustain you, not just for a short amount of time, but throughout the entire course of your studies. So it needs to be something that excites you, that you really, really want an answer to. So in this series of lectures, tonight being the first one, we're going to try and help you understand what is required in a doctoral level of research. So we're going to start by exploring some of the different research methods and methodologies. Experimental design, ethnography, case studies, survey methods, all of that stuff, comparing qualitative and quantitative methods. And both have their value, both are important. At the end of the day, what we really need to do is understand a combination of both of these. So what we're trying to do is find out something that works both, well, not just measuring something, but putting understanding, and everything's going to overlap. So we're going to cover off some of what each of these are. So first of all, what are the goals in science? And this is all really going to be a scientific study. Even when we're looking at management and some of the other softer sciences, then the idea is to understand, predict, and control. Why are we doing things? Well, so that we can make our environment better, so that we can understand the world we live in, and that we can have some way of predicting the outcomes. If we send a rocket into space, we want to know where it's going to come down, what it's going to do. If we build a bit of software, we want to know what it's going to do, how it will react with different scenarios. All of these things are important. So as an IT researcher, as a scientist, as an engineer, we want to also then take what we've learnt and help teach others. So it's a fundamental part of research to disseminate what you've done, to communicate your discoveries, to basically help get your research out there to your peers. So let's start with an introduction to research. How do we think about research? Whether we're looking at engineering or science or whatever else, it's important to understand what we're trying to have as a goal. So we have an outcome. Research in a way is a project like any other activity that we're going to do. It's a one-off with a beginning and end and a specific goal. Research isn't an operational issue. It's not something we do day in, day out, although some people would argue that with me. I'm still in university after many years, but each time is a separate project. So I'm a serial researcher, and what I have are a series of projects one after the other. What you will be doing will be a project designed to find, well, a particular answer to a question. So to do that, we need to start by scoping the exercise. This should be something that is around your particular area of study and expertise. It's no good picking a topic that you have no knowledge of. At the end of the day, you need to find something that interests you, truly interests you, and run with that. To do this, you need to know the variables that you're going to try and understand and, well, basically report on. And you also need to have a level of rigor. So, anytime we're doing this, we need to understand the level of research that we're doing, and we need to be able to replicate these results so that other people can understand our work and others can also take, well, what we've done and apply it. Part of what you need to also do is come to understand and appreciate research articles. You're going to be doing a lot of reading. Any doctoral study involves a lot of reading. Part of what you need to do is understand everything that's already been done in the field, or as much of it as possible. So, we have a lot of this that you need to go out there and find and dig up. And you need to understand the challenge so that you can create a cogent basis of what you've done and report it to the world, so that we can actually show the evidence that we have and why your research has value. So, in starting this, we'll start with actually designing the research. What do we need to do? Well, first of all, what are we looking at? Is it theoretical or applied research? What questions are we seeking to ask? Are we looking at a natural environment, for instance, or are we creating an experiment, a simulated one? So the difference there would be our settings, whether we have something in the lab or we go out and we investigate the natural world. The research investigators, who is it actually going to be doing this, and what experience and background do they have? And we have a continuum. Experimental, ethnography, case study, survey, and this is only touching the top of the iceberg. There are many more than that. At the end of the day, there's very rare anyway for any experiment to be totally one or the other. So we have both quantitative and qualitative methods will overlap to some extent. More in some cases than others, but we generally have some of any of this. So, why? Now, first we need to understand these methods. So, as part of your studies, you need to really come to an understanding of this. And as part of what you're going to do in a doctoral program, the Doctor of IT, for instance, you need to perform a critical study of what's out there. What papers, what research, and what methodologies have been used. And you're going to have to apply that to your own research. So, to start a proposal, you need to think about which research methods are there and which will actually suit your research topic. So that's something we can't answer for you. Your supervisors will help you and guide you, but you have to come along and work out what is the best way. So this is a self-guided exercise in some ways as well. So you're going to be the researcher finding these things out. We teach you how to research, but you have to find out the problem and the answers. So all research approaches have both a strength and weakness, and depending on what you're doing, you need to understand how they fit with your topic. So quantitative, qualitative, whatever else will have pluses and minuses that you need to apply, and depending on what you're doing, you need to address the weaknesses and choose things with the strengths and basically approach all of those issues. Take the tools that are there. Maybe you need mathematics, maybe you need statistics, maybe you need to learn new software applications. All of that will be part of your research. So, if we're looking at empirical research, we need to identify and understand the procedures we're using, and this then forms part of your research proposal. So in creating the type of research you're doing, part of the structure of the Doctor of IT is actually going to be taking what you've done, creating a research proposal based on some hypothesis, a question that you have. The hypothesis is, what am I trying to prove or disprove? Then you need to find out and take all of that information, all these survey methods, collect it all together, and then find out what data you need, what methodologies you need, and what theory already applies. So you have a look through the slides later in more detail, and we'll go into this as well. But what we're going to start is researching the problem itself. So we need to define, the first part of our research is actually defining the problem. So we look at the real world context here. Is there actually an issue? And then we can look at the various and variety of research questions that could come out of that. Maybe it matches with different philosophical positions, yours and others. Is that valid? If there's a match, maybe you want it as your research objective. If not, maybe you go back and you go to the drawing board, etc. So the main part of the continuity here, the continuum, is between quantitative and qualitative. But you'll notice the goal in each case is to understand and predict and control. So qualitative, to understand and predict. In both cases we're trying to predict. Quantitative, we're predict and control. So if we can't measure, then we can't manage, is one thing that I like to say in some of my project management classes and other things like this. And quantitative measures are good. They give us something that we can have a look at what's happening and measure the world. So in a quantitative, we're trying to measure the values of what happens and then be able to generalize our sample, because we can't generally go out and survey every person on Earth. That would be difficult, to say the least, if not extremely costly. And even then, we don't know what percentage are honest versus dishonest or whatever else, so we can't even take a snapshot of that. And what we measured today is only a sample as well. If we measured everything from every person on Earth, it's still only a sample, because tomorrow they can change their mind. Their situation may be different. All sorts of things such as this. So what we're doing is trying to find a way of generalizing our data. So quantitative is both basic and theoretical, and revolves quite often around hypothesis testing. So we're looking at statistical tests to see whether if we do case 1 versus case 2, which we'll explain a little bit more at the end of this particular lecture, whether we can actually say yes, there's evidence to support A or B. And quite often it's a lab study in a controlled environment. Qualitative, on the other hand, we're trying to understand, once again, we're trying to predict. We move towards more descriptive accounts. Look at the similarities and contrasts between organizations. Maybe Google is good because. Maybe this particular organization is good. And we can look at things like case studies and apply those to what different organizations actually do in the real world. And it's both applied and theoretical. And we have different research questions, quite often based on natural study conditions. So actually going out there and interviewing and looking at existing organizations. So qualitative, ground theory, ethnography, right down to things like critical feminist theory and phenomenology. So looking at things that occur. So we have all of these things, and all can even be part of an IT degree, because contrary to what people may try and tell you, at the end of the day, technology is about people. One of the things I try and get through to people, my research areas of course being risk and security, is it comes down to people. It's about trust. And you don't have trust from cryptography, you have trust from people. So at the end of the day, the human is a big factor in all of these things. Quantitative, we have both non-experimental or descriptive measures, randomized trials, ethnography, content analysis, etc. So there'll be more reading, and I'll be pointing out some of this at the end. And if you have a look at the slides, you'll be able to get a whole lot of different reference texts and other things you can have a look at and learn a lot more. Now, just as a side note, one of the things we're doing in this series of lectures is we will then, at the end, have an exam. So the final week, you can get a certificate. If you learn all of this, then the university will actually allow you to come away with a certificate saying that you have done research methodology. We're offering this for free. Of course, it's part of trying to get people to see whether they would be interested in going right down the path of a doctoral study, and we're trying to push that. But at the end of the day, in this series of lectures, if you do the work and you do the study, we have an exam at the end, and if you get that, then we are giving out a certificate from the university saying that you have done it. So, evaluating research. Part of what you're going to do, and others will do on your research, will be evaluate the quality of your research. So when you're doing your literature review and looking at what's already occurred out there, you will do this, and then others themselves will also do this against what you publish. So, evaluating research. We got the validity of the data. Is what we're doing actually worth what it's going to say? Is it actually valid data? Does it really reflect the population that we're saying? Is it done in a non-biased way? And we're talking statistically non-biased as well as everything else. Is it reliable? If someone else ran the same experiment, would they get completely different results or not? Is it useful? What value does it have? Does it actually advance the theory or practice? Does it make your profession better? Does it actually add something new to the world and contribute to knowledge? That's what we're doing when we're evaluating research. So, overall research questions. What do we want to focus on? What are we doing? So, why do we want to do this? What do we want to know? And, well, what boundaries to the research do we have? So we have different contextual issues of different people involved in all our research. Our subjects for our research, of course, they're going to have involvement. So we also need to think about those who are helping us and others in our lives. Those that we're working with, those that we're going to be involved with, will help control both the vision of our research and focus our activities. They'll take our time, but they'll also give us what we need to succeed, and we need to work through all of that and look at what we're going to achieve. So validity and reliability, no matter what we're doing, quantitative, qualitative, doesn't really matter. We're seeking valid results. So if we're looking at quantitative reliability, is it consistent and stable? Can other researchers do this? Now, many in science don't believe that until you actually have someone, another scientist, an independent body, come and replicate your experiment, that it's not really valid. So there are people who still have that way of looking at things. And if you can't replicate things, then your research doesn't have a lot of validity. It needs to be reliable. And then we also need to make sure that we take a true picture of what's under investigation. We need to make sure that we have actually got to the fact of the matter and that we understand what we're doing. That people haven't lied to us, that the population sample we've taken is in fact indicative of the population that is out there that we're talking about. And in this, the part is often different to the whole. The whole is maybe greater than parts, and maybe we can't extrapolate things. In putting it together, we are trying to infer the behavior of an entire population from little bits and little samples. And that can be non-trivial. It can be difficult. It can be truly difficult to actually put these things together. So in quantitative research, what we're trying to do is find out the causality. We want to look at why things occur in many cases. So remember the old adage, correlation is not causation. There are reasons for why we want to find correlational data, but at the end of the day, the ideal thing we're trying to find is the cause. If I do A, what happens? Is it B, C, D, etc.? So we want to isolate particular variables and study the exact effects. On the other hand, qualitative data, we're going to look at a holistic view of things. looking at documents, case histories, maybe investigate what happens in a particular organization, why these things occurred, interview and observe different things. Maybe we think Google was particularly good because these types of people were leaders. Whatever else, we want to explain all of those sort of aspects of it all. And to do that and to further our research objective, we need to collect data. Data is important, both from a quantitative or qualitative measure. So in quantitative, we're really emphasizing numerical data. That could be financial data, length of time. A couple of the things I've used in some of my research have been either of those, looking at the economic impact, so taking the cost, the profitability of security and risk, or looking at the time to respond is another one. How quickly do people actually find an intrusion? How quickly do they go out there and fix it? And so these are things we can measure, and they're variables that we can then measure. Whereas qualitative, we're looking at observing and interpreting different results. So it's a natural thing that's actually occurring now. In many cases, it can be quite difficult to set up a quantitative experiment. We can't go out there and set up a idealized company and see how it progresses in the real world in most cases. The money, the ability to do that and play with people's lives doesn't allow it. And this, of course, goes in both static and dynamic. So looking at time, maybe we're doing time-based things. One of the areas of my statistical research has been heteroscedastic, which is basically time series type data. So from a quantitative point of view, looking at how things move in the future, whether we can predict what may happen based on the past. And sometimes we can, sometimes we can't, but we need to understand where, why, and how. And qualitative, maybe looking at things at a point in time. In this environment, Facebook thrived, that sort of thing. In a different environment, maybe they wouldn't. Why? What particular strengths in that type of environment did they do? So in doing that, we have many types of research, from experimental design, setting up our own things, ethnography, which we'll cover in a bit, case studies, such as you see quite often in things like Harvard Business Review and whatever else, looking at individual thought leaders, businesses that are ahead of the pack, all of that, or surveys. And I'm sure you've all seen surveys, SurveyMonkey out there online now. So, first of all, looking at experimental design, what we're trying to do is find a hypothesis that we can test and create something that will allow us to find the independent and dependent variables. So allows us to create something that will allow us to predict. We can predict the future based on this. That's what our aim is. We want to be able to predict the future so that we control the output of what we're doing. So maybe if we instruct people in certain ways, if we have certain educational frameworks, that will have different results. Maybe if we have different types of math tutorials, we get better performance on math exams, that sort of thing. Maybe there's sampling of the population. We can go out there and measure the different results from different people. We need to understand the strengths and weaknesses of various types of sampling. We have experimental and controlled conditions. The ideal is if we can make some sort of, well, environment that is like the real world, but we can control. The reality is we're going to have different weaknesses with doing that, but strengths in what we can do. And even if we can randomly assign things, we might not be able to do that in certain real-life experiments or whatever else. So experimental research, what we're trying to do is create a set of models, inferential statistics, that allow us to measure the size and report on what we're doing and determine what changing one variable will do to another. So we can create a model. If I have this number of attacks and I do this sort of response, this is what will occur. That's what we're trying to do here. So experimental research is really about some sort of control predictor. If I see someone looking at attacking my website, then this is what's going to happen. Or over time, I can start judging whether I'm going to be attacked based on these sort of things. Then we have ethnography. So this is going native, the old anthropology look at it, or psychology. And this, of course, is a valid approach to information technology research as well. We're going to be able to look at how particular organizations do things. Maybe we're looking at IT leaders. How do people in this field, those engineering companies that are considered the leaders, how do they do things differently? And we might spend time doing field work, going native, working with these people, understanding their business. How did Sergey Brin do Google? What did they do to make it grow? How does Zuckerberg do Facebook? What did he do to make it work? How did he interact with people himself? How do you interact with these type of people? And what we're doing is a qualitative measurement, and we're trying to get an account of what works and what doesn't. So other things, field research, we can look at observation, just passively, actively being part of things, interviewing, whether we do group surveys, questionnaires, structured or unstructured. There are different, you have to learn the different benefits and costs for all of those, of course. We have to make and use records, historical documents, archives, written records, all of that. Have to know and understand all of these things, and we can pull them up and analyze all of them. Some things may be such as, well, if you look at the Wayback Machine, the US Library of Congress has a snapshot of not all the websites of the world. Not everyone wants everything taken, but a snapshot of the majority of websites out there at any particular time are taken and snapshotted and archived for all history, or as much as they probably tape at the moment. And that's an archive of these things that we can investigate. Case studies, we can look at particular types of organizations. Maybe if we're going to take, well, software programming. There was an article the other day talking about how we should be teaching our children how to program right down in kindergarten. And there are even some US programs now that are moving towards educational programs of taking individuals and teaching them how to program right from kindergarten. Here in Australia, we have some things for some people in university. Should that be in primary school? So we can have a case study of individuals. So we can take a single child who started learning right back at kindergarten, a single classroom, this particular class of people learning Python in high school, a single school that had a program that pushed all this to everyone, national program maybe. We can have those as our case studies and investigate. So our goals there are really to look at what these different individuals, different projects or whatever else are doing that is unique, and to try and find out why they're unique and why they work. So in case study methods, we're really doing social research, asking, watching, reporting, and then looking for the things that occur again and again and make them work and make them good, make them effective. So in doing this, what we're trying to find out is an answer to our research question once again, but by finding the look and pattern of what we're doing. So what pertinent research questions do we have and we need to answer? So validity and reliability, different stories to be told. Different people have different things. And it's not even about lying or fraud or anything like this, but people will put different values on what they talk about and what's out there. And they may discount, they may not care about certain aspects of what you're talking about. So they may be something that they see there, but they didn't think about it. So maybe, well, there's issues they don't even think about. So validity and reliability, you have to try and pick the needle in the haystack out of different consistent and inconsistent stories and use those to find patterns that maybe you can use to predict the future out of. So our survey methods. First of all, we have to look at what our population is and what goals we have. Are we looking at people, objects, institutions, government versus corporation? What are we trying to do? And then understand the different conditions that we have. Because it's not quite the same as experimental research. In a survey, we're not going to be sitting there controlling our environment. We can't say who will walk past us. We can't say who will answer the phone. So in our sample population, our group of interest or whatever else, we have to say that somehow maps out and measures the real world. How do we do that? How are we assured of it? And that comes down to some of the different issues with methodology versus like things like mail, web-based, face-to-face, telephone. Are people going to actually participate in all of this or not? And some of these are going to be more or less likely to bias particular aspects of what we're doing. So if we have web-based, for instance, and we're looking at different uptake of, well, maybe a new project, and that project has nothing to do with the internet, and part of it involves poverty programs and things like this, maybe half of the people who are the population we're trying to test don't actually have a computer where they're going to have a web-based access anyway. So maybe we're not actually getting the population as a whole, and those who are answering are going to be biased to some level, in which case, well, we need to investigate what we're doing. So survey construction, we should look at how we're doing it, what sort of questions we're answering, how they're set up, no leading questions, pilot testing, and then revising and going over and create the ability to generalize and draw conclusions about all of this. So we want, at the end of the day, to understand the population that we're taking. All of these different ways of doing things, of course, produce results. Okay, so academics, well, what we do and what you will study is something that gives you not just information, but a result. You have a set of quantitative and qualitative measures that allow you to report on quality. You can look at all of this, and what you do then matters on what you sell. Your selling point is what you have done, and to do that is getting your results out there. People have to actually read your work. You want people to understand and use what you've done. You want this to be of value. So to do that, that's where we get into quantity and quality. So quantity, where are you publishing? How many people are reading? Quality, the reputation of where you're putting your research. So first of all, different journals, different conferences, different books, and there are differences between journal publications and scientific journals, engineering journals, and whatever else, such as those by Computer Society or IEEE or Harvard Business Review or whatever else. And there are some low journals that only a few people read. The particular aspects of certain types of artificial intelligence may be highly detailed, but maybe they don't get out to many people. So we need to think about the quality of the publication. If we're publishing in something like Science or Nature compared to Concordia University Journal of Management or something like this, that not many people would read. So we need to think about where we're putting it out, and then what benefit we're actually offering from that. So our research objective comes down into certain purposes. We want to explain, ideally find causality between different observations and a reason. Why does this phenomenon occur? We can explain what's occurring in the world. Explore something, maybe find what a problem is. Sometimes it's not even answering what the problem is, but finding that there is a problem in the first place and allowing a new field of research to open up to try and find some answers to that problem. Or describe, where we observe and visualize a situation and phenomena and say this is what's actually there. So in that, there are different research objectives. We want to explain, explore, and describe. And each bit of research will generally have a little bit of each of those concentrating on one main area. So your research objective doesn't really define whether you're going to need quantitative or qualitative research. You're going to need to go through and find what's best for you to come up with your answers. And in doing that, we need to take, well, where do I need quantitative data? Where do I take qualitative data? So I've taken a slide from Qualitative Research Methodology by another researcher's seminar series. And in there, what questions are there? What descriptive? How much? How many? What are we doing? What explanatory things do we need? How are we going to explain or explore? And how? Why? etc. So the normal what, where, how, why type questions that we want answered in anything become the focus of our research and our objective. So qualitative research and quantitative research overlap in many cases, but in qualitative we're wanting to look at the meaning. It's not right or wrong. We want to understand a phenomena, not say whether it, not judge it. Okay, so that's what we're trying to do. So here's the full model of what we're going through, and I'll leave you to have a bit of a read through this in detail. Where we go, this is basically the flow diagram of how we choose what we're going to try and get as our research project. What sort of theory we're going to do, whether we're doing deductive or inductive logic, whether we're matching different technologies, etc. So have a bit of a look through that later in the slides. Next, where do I get my ideas? Okay, where do ideas come from? And these are going to be all different sources. So literature reviews, newspaper stories, research assistant work, mentors, teachers, your subject coordinators, fellow students, clients, field experience, experts in the field, people you're helping, etc. Anything, multiple sources, all over the place. You get ideas from anything. But you might be reading a newspaper article and then bing, something hits you. That's where we get our ideas. But you need to start thinking about and researching all of this. At the end of the day, it becomes important for you to do it.